Thank you, Magda. It's a pleasure to be here. We're a bit on a double agenda. We came to work with the Polish team on our program, and on the when we heard about this event, we of course had to take this chance and sort of tell our story to you guys. The other part of the agenda is we're hiring, believe it or not. We're seeking talent, and we come all the way from the UK to find talent to help us on a global journey. My name is Mark Simons. I'm the Global Cloud Program Director for Aviva. That means for the whole of Aviva, globally, worldwide, about 20 countries, we're having a program to go into the cloud. And that's a massive undertaking. Somebody asked me, what's your job? The simplest way I can explain is I'm teaching a dinosaur to figure skate. Yeah? And why do I say that? Aviva is a 320-year-old insurer. We sold our first policy 320 years ago, and we were the first insurance company in the world doing so. At the moment, we are, depending on how you look at us, either the largest or the second largest insurance company in the UK. We do business in over 20 countries, and it's a massive beast. It's a big company, yeah. And as it goes with insurance companies, you have a lot of IT. IT is one of our largest cost bases. And to bring that estate into the cloud is not a small program. It's a big program. And that's why I say I'm teaching a dinosaur to figure skate. Yeah? Aviva does realize that the digital revolution is and will change and disrupt the world. Yeah, we see that. We see it everywhere. We feel it every day. And we've been on a journey now for, Paul, 3 years? Yep. Setting up sort of our own digital garages. We disrupt our own business from internal. And if you look and watch videos of our CEO, Mark Wilson, you hear him talk that he wants to make Aviva, as big as it is, a fintech company. So what is he doing? He's actually instilling sort of startup mentality in a large business. And that's what we sort of facilitate. So the cloud program is the underlying what we need to do to make the rest of the company a startup. Because you cannot do that on mainframe. You cannot do that on ancient technology. You need to be agile. You need to be quick. You need to be able to do all the things that the cloud offers. Now, what we do, and we're talking about that today here, is we nibble off the estate, whatever we can, and bring that to the cloud. And we use the latest technologies, we use the best technologies available to do that. The reason Chris is not here, by the way, is very simple. We told him the event would be in Polish. And then we booked tickets and said, don't watch the stream. Yeah, but I'll promise you, we'll send Chris over for one of your next events, because we will have a continued story for you guys, and we will be working with Aviva in Poland, the team here, extensively also to bring Poland to the cloud and into what we do. With me, Paul Russell, digital CTO. So he has a key part in my project on the technology side, and he is the technologist here. I'm not. I'm the least technical person in the room tonight, so I'll... Magda, you and I go for a beer afterwards, talk about this, because if I see code, I normally watch away a little bit. I'm just not a... and our architect, Darren, and they will introduce themselves in their parts. We're going to do this in 3 parts. I'll do a quick introduction as to why we do this, and then I'll hand over to Paul to tell you all about what we've done to date in building a platform for Aviva. And Darren will then take you on sort of the initial stages of what we call our migrations and our factory. So how are we going to do this? How do you bring data centers to the cloud, applications to the cloud, business to the cloud? More important, and here is where it often goes wrong, how do you bring people to the cloud? Yeah? In many of these large, big projects, it's not the technology that's actually the issue. The technology will solve itself with bright people. But how do you get an organization to deal with cloud and what cloud does to the organization? That's the hard part. It's as much an organization, a reorganizational project, as it is a technical project. So why do we do this? It's very simple. As I just said, IT is one of the largest cost bases in the insurance industry. Yeah, we have a lot of it. If you guys come to an insurance company and you want to buy a life insurance policy, both of us actually hope that we don't have to touch that thing for 30 years, isn't it? Or 40 years, or maybe even 50. In the background, that's also what happens to the systems. That policy sits in a system, and that system gets older and older and older and older and becomes legacy over time. Yeah? And legacy costs money, a lot of money. And one of the things why we do this, cloud gives us the variability, it gives us the flexibility, it's also a lot cheaper if you do it well, so we want to reduce cost. Yeah? We want to get more secure. We are a financial services company. What we sell is trust. We sell trust on a piece of paper. People don't trust us. We have no business. So we need to make sure that we stay secure and that we don't become subject to all the things, the bad things you hear about nowadays on hackers and insecure businesses that have been hacked and deal with the consequences of it. Also, we want to automate. We need to be much more efficient in how we run the estate, how we take cost out, how we speed up our business, our time to market. On the other hand, we're not the only insurance company doing this. Every one of the insurance companies feels that this is going to happen, isn't it? The digital disruption is either around the corner or it's hitting you full in the face. And in order to keep our competitive edge, we've decided to go at it full front. We opened digital garages in Canada, in the UK, and in Singapore. We attract people, like here in the room, to help us develop what the future of insurance looks like. And we try to disrupt our own business as well as our competition. Yeah? The other big thing is resilience. Yeah, so in the old world, you have DR data centers. In the new world, you have resilience in multi-zones, availability zones in the cloud. We need to make sure that our business is up every day, all time, 24 hours, 7 days a week. Yeah? So the cloud gives us the ability, the technologies to do that, and not being sort of dependent on old technologies and having to do failovers and DR tests and stuff. So all of this, in a period of a couple of years, will bring Aviva to its next stage from a technology perspective, but especially from a business perspective. I'm going to hand over to Paul now. Paul's going to introduce you to sort of the technical side of this story, and then later we'll talk about the migration part. Thank you.
Hey everyone. So I'm Paul Russell. I am the kind of token nerd from the UK side. My background is programming. So I started off as a kind of Java developer back in the day, and have kind of grown up through that rank and now look after the kind of technology side of the cloud program. And as Mark said at the beginning, I'm just about to pick up a role looking after technology for our digital business unit. So I'm going to go through at kind of fairly high level what the heck it is we've built in the UK and why we've done it that way. I'm not going to get as detailed as we got in the last session, but I'm more than happy to talk to anyone afterwards about any details here that kind of sound interesting to you. I think one of the key things to kind of understand about what we're doing is the scale of it's massive. So we are a big company. In the UK, we have around about 1,000 IT systems deployed. Those are hosted in kind of traditional data centers currently in the main. And we want to be able to move a significant fraction of that into the cloud. So that's tens of thousands of servers, basically. So it's not small. And as a company, we're global. So we operate here in Poland, and we operate in Singapore and Canada and various other places in Europe. So we want to be able to kind of work on a much more global scale than we've been able to do in the past. So the platform that we're building here is currently running in Dublin, but our intent is to roll that platform out in Canada, Singapore, and Frankfurt as well in Germany. And one of the key reasons we want to do that, one of the key reasons we want to roll that platform out globally is, as I said, I kind of come from the digital business unit, and we want to be able to take code that we write in London or code that we write in Canada or code that we write in Singapore and deploy it globally at the same time. So we don't want to have to kind of deploy it separately in every individual place that we want to work. We want to be able to write that code, press a button and watch it go live globally. So that's kind of ultimately from a digital business unit what we're looking to do, and cloud's an awesome way to do that because we can automate everything pretty much. But it also gives us lots of other opportunities as well as a business. So the platform, just to kind of explain the platform that we've built, it's not, so often when people get started with Amazon, they create an Amazon account, they stand some stuff up in it. So we were talking earlier about creating VPCs and running instances in those VPCs using Spot, for example. The platform that we've built is more complicated than that. So we have multiple accounts and multiple VPCs. We have separate accounts for production and test. We have management accounts. We have an account that we use to connect to the internet. And then we have lots of application-specific accounts that host individual applications. So it's quite a kind of gnarly, complicated thing. I think at the moment in the UK we've got, I'm trying to remember how many accounts it is, something like 6 application accounts, internet gateway and management in non-production, and the same again in prod. So you've got kind of 12 accounts that application teams are using to do what they're doing. And that'll grow over time. So it's quite a complicated beast. All of this is scripted. So we use a tool called Terraform. So we were looking at Ansible earlier. We use a slightly different tool called Terraform, which is pretty awesome, by the way. It's a really good tool. We can talk about it some more later. And everything we do is scripted. I was having a look at the code while I was sat over in the corner earlier. And we've got 84 Git repositories that represent each of the kind of components that we deploy in that environment, and that's before we put any applications in it. So that's just the kind of skeleton of it. So it's quite a kind of big beast. We do everything through automation. So we use, like many of you probably, we use Jenkins for automation. We use Bitbucket for hosting code. We use Terraform for kind of automating all of the deployment. Packer for making AMIs. We use Vault for storing secrets and doling those out to applications, and we use quite a lot of Lambda as well, quite a lot of AWS Lambda to kind of watch what's going on in the platform and control what's happening in there. We talked earlier about security, so nobody wants an insurance company to get hacked, right? That wouldn't be good for anybody. What we've tried to do here is to make a platform that's more secure than a data center can be, okay? And you can do that in Amazon because of some of the tools that they provide you. So this is just a bit of a list of the kinds of things we've had to think about. For fairly obvious reasons, given we're on camera, I won't go into any details right now about how this works, because that might kind of spoil the point of having lots of security. But again, I'm happy to talk to people afterwards if they're interested in how we tackle particular bits of this, but just to give you a kind of quick rundown. So anti-DDoS, does anyone know what that is? Dealt with that before? So you hear about lots of hacking attacks where people are sending very large amounts of traffic to companies to try and knock them off the web. So anti-DDoS is about preventing that. We have web application firewalls, which are to do with making sure that people can't do things like SQL injection attacks and cross-site scripting attacks against our applications. We've got a very heavily segmented network, so each app's split from every other app, etc., just to make sure that if anything did get attacked, that nobody can kind of skip around internally within the network. We have anti-malware, which is about spotting things like the Petra malware that was around and WannaCry and those kinds of things. So making sure that we can spot anything like that that's going on. Not that there was anything going on, just to be clear, but you understand what I mean. We have intruder detection and intruder prevention. So again, we can spot people, anybody doing things they shouldn't be doing in that environment. Vulnerability scanning, so that's looking for any misconfigurations on servers that can cause problems. We encrypt pretty well everything, so if it's stored on disk, it's encrypted. We have lots of tools that are watching everything that's going on in the environment and spotting any kind of anybody breaking any rules, basically, and fixing it. And we kind of automate the patching as well, which I'll talk a bit more in a minute. And on top of that, we've got kind of 24/7 security monitoring, which actually we're setting up in Poland, is the plan. Image management, images in Amazon are kind of templates that you create servers from. So many of you probably understand all of this and know this, but just in case you don't, that's what we're talking about here. We automatically create images. We use Jenkins to do that, so we basically have code that defines what our images look like, and Jenkins basically runs that code and automatically spits out a new image on a regular basis. Application teams then have their own images that they bake on top of the base ones that we create. And again, you can kind of automate that so that they just run. So our base image comes out, and then the application images get automatically created, and then they can deploy them. And we use a bunch of tools to do that. So we talked about Jenkins already. We also use Packer, which is a HashiCorp tool. We do some security scanning of that, which I'll gloss over. We use ServerSpec to test that that image is behaving the way we're expecting it to do. And we use Ansible, we talked about that earlier, Puppet, PowerShell, and various other tools to actually script the software onto that image. Patching is a big deal at the moment. So if you've seen the WannaCry attacks that have been happening recently, that's been due to companies not keeping up with patching, basically. So there was a vulnerability discovered. Microsoft patched that vulnerability. Companies are quite slow to adopt and roll out patches typically, especially big companies, because it's very hard to patch a very big estate very quickly. So we want to automate as much of that as possible. So the way we do that in this environment is basically by baking new AMIs, so new images, that have all of those patches baked into them. Application teams then bake new AMIs themselves, and then we can automatically roll those out to test environments, test those images, make sure they're happy, make sure the applications still work, and then roll them out to production, basically. So the intent is to make that whole process as automatic as possible. Yeah? Yeah, sure. We haven't got CD yet, so we basically have the tools that we need to do that, but we haven't got as far as getting CD fully in. Partly that's because, obviously, to do CD really well, you have to... Sorry, just to repeat the question. What was your name, sorry? Michael. Okay, so Michael was asking whether we do continuous delivery, which is all about pushing code up to live with as few kind of human touches as possible. So we have automation for doing all the deployments in the various environments, but we don't have the kind of end-to-end to push it all the way up to production yet. But that is definitely where we want to go. It's just about making sure we've got all the right automated testing around it before we do that. Okay. When we do deployment, we use Jenkins again, so same Jenkins platform, and we use Terraform, which is another HashiCorp tool to roll out new deployments into that environment. Has anyone in the room used Terraform? Come across it, a few people. So it'd be interesting, given you use Ansible, that'll be an interesting conversation later. So Terraform basically is a tool where you declare how you'd like your environment to look. So you can say, I want a network subnet over here, and I want an auto-scaling group here, and a load balancer here. And Terraform's job is to make that happen. And what's clever about it is it can look at what you've deployed before and what you're asking it to deploy now, work out what the differences between those two things are, and build itself a plan to get you from where you are now to where you want to be as quickly as possible. So it has some similarities with Ansible, but it just deals with it in a slightly different way. We use Terraform across the whole platform, partly because of the way it does that deployment, and partly because it supports kind of multiple cloud providers and things like that. So in the future, we can use it to do other things. Where we're wanting to go with this eventually, which kind of comes back to your point about CD, is we kind of see ourselves as having two big types of applications. We've got traditional apps that are kind of, whole VMs, basically, so whole virtual machines that need to be deployed. Most of Aviva's apps right now are in that category in the UK, so we have big kind of contract engines and things like that store your policy data. Those are kind of typically big applications that run on a whole server. They take all the resources of that server, and typically they're much harder to kind of automate and move around. And then our digital estate is much lighter weight, so it's stateless, and it can be put in containers, and we can deploy on top of a container platform. So the intent of the platform is to support both of those styles of deployment. Right now, we're focusing on getting the traditional way of doing it done first, because most of our apps fit into that category. And also, you kind of need to have that traditional bit done in order to then be able to put a container management platform on top of it and then deploy using containers on top of it. But our digital business, we're going to put as much as we possibly can in containers, because it just makes it much easier to manage and much easier to deploy. Okay. I'm going to skip over these ones. So this slide just shows all of the various things that we've had to build. So we talked a bit earlier about having to worry about security and having to worry about various other things. If you're a startup, you kind of don't have to think about security in quite the same way that we do, and you probably don't have to think about how you're going to get 2,000 or 3,000 developers to move their apps onto the platform. Hopefully, if you do, you're a very successful startup. So what we've had to think about is building lots of individual capabilities that kind of together help those teams do what they need to do. So we've talked about kind of malware scanning and vulnerability scanning and things already. We've also got kind of a central logging platform. So we use a tool called Splunk to support that. Again, a lot of you have probably used. And a whole bunch of other tools that we've had to put in place to allow teams to kind of use the platform as easily as possible. So again, a lot of work's kind of gone into making that work. And because we've scripted it all, the intent is that we can take that same set of things and deploy them in Canada and Singapore and wherever else in the world we need to get those deployed. Okay, so that's it. That's all I'm going to go through in terms of slides for the technology, but we can come back later and people can ask questions. Okay? Aaron.
So I'm Darren. I work for Chris. The reason that Chris isn't here is because his passport expired, so that we've had to take over his role. But what I want to talk to you, so I'm a cloud architect on the program. I work for Chris. Currently, I'm concentrating on how we're going to do the migrations of all of these apps and all of these data centers into the cloud. So I'll cover that quickly. Then I want to talk to you about DevOps, because then that sort of flows into how does our DevOps model look like for Aviva? Because for a large enterprise with varying technologies and varying skills, it looks quite different to, for example, a startup company would look like. So this might be hard to see, but we've got 1,000 applications. How do we go from going to those 1,000 applications from the data center into the cloud? So, and at the same time, we have a lot of dependencies. So we've got the platform that Paul's team are designing and building. How does that come into working out, well, which application needs which platform feature at which time? Because we can't build the whole lot instantly. It's a lot of engineering effort. So it's about lining all of that up with the platform build, with the dependencies. So we start by looking at all the applications and we do a discovery on the application. So in that discovery, we look at the application architecture and we say, okay, what's this going to look like in the cloud? And what features does it need? Does it need secret management? So something like Vault. Does it need an FTP? Does it need, what AMIs does it need? Does it need Windows 2012 or 2016? We would look at all the different platform features that we need to build and work out this application needs this application needs that. And that way we can build a view of, we have 1,000 applications. If 400 of them need this platform feature, then obviously that's a really high priority for us to build that first. If there's a platform feature that not so many apps build, well, that probably isn't, it comes down the list. We also look at how complex that application is. So, how complex are the integrations? How complex is the architecture? Everything else about the complexity, like how many things do we need to refactor? Do we need to upgrade the OS? Do we need to transform the database? And that gives us a view on how quickly we can migrate that application to the cloud. We look at what technologies they want. So if they want to go from servers to serverless, well, we need to make sure that if we want to use Lambda, that's an Aviva-approved technology. So the information security team need to look at that and say, we're happy for you to use Lambda, but only in these specific use cases. So we need to get a view on that. We also need to get a view on the application team's skill in terms of DevOps, in terms of automation, in terms of the cloud. So some application teams like digital, for example, are very well versed in the cloud, used to doing CI/CD pipelines, containerization, all of that stuff. Great. Some application teams don't have a clue what the cloud is. So we need to work out, do we need to help them? Do we need to provide resources to migrate that application, or can you do it yourself? So that's another thing that we do when we do the discovery. We go through an exercise of assessing, prioritizing them, working out what the platform backlog looks like. So which features do we build first? Which are the higher priorities? what technologies need to be approved, and then work out what the overall migration roadmap is going to look like. And we do an inception on the application migration. There's all these different teams which do different things, and then we have kind of an accelerated migration program and like a standard refactor migration. So, if these are for like the simpler apps that we define, the standard refactor for if you want to completely go server to serverless, then that's a longer process, longer design, more involved. If you're not changing much in your architecture, well, then we could migrate you faster. There's also things that which you need to request, like capacity requests. So which VPC do I go into? How many IP addresses do I need? What account do I need to go into? In that large platform that Paul described, where do I fit in there? What external dependencies do I need to raise? Do I need to raise a firewall request with our third-party vendor? That takes a while, so we need to do that as soon as possible. Along the bottom here, we have a governance process. So, we're a heavily regulated financial services organization. We can't just build stuff and stick it in production. We need to go through, make sure that we're providing the right designs, that we're checking to see that, how much is this app going to cost to put in the cloud? Is it, does it cost 50 quid a month to run it? Is it going to cost £500 to run it in Amazon? Why would we put it in Amazon if it's going to cost 10 times more? So we need to do all of this governance work to make sure that, what kind of data are we putting up there? Does it need to be encrypted? Is it personally identifiable information? This is the governance process, handles all of that. So, that's that at a really high level what the end-to-end migration factory looks like, I guess we're calling it. If you're familiar with Amazon's methodology in migration applications, they talk about the 6 R's. So there's retain. Do you retire it? Do you rehost it in Amazon? Do you replatform it? Do you refactor, which is like redesign, or do you just replace it? So we are following the same principles, and we are looking. The things which we're targeting to go into AWS are the rehost. So this is like a lift and shift of an application. Are we looking at a replatform? So you might be changing the OS version just to upgrade it to the latest one, or are we refactoring? So are we redesigning this application and re-architecting it? The retire, the retain, and the repurchase are currently not in scope. So this is going to remain in an on-premise data center. But where we may repurchase or we retire an application, if we buy a new one or want to build it again, then obviously that would go down into the AWS. So I want to talk about the DevOps models. So this is a DevOps MeetUp, so I'm pretty sure everyone understands what that means. I'm not going to sort of cover it, but the very first project I did in AWS, I was fortunate to work. It was in Australia for a government agency that managed the travel for the state, and we worked in the digital division of that company, and we built like a customer-facing web app which allowed people to plan their travel. And I'm sure you guys have it if you've gone to London. They have the trip planner. It was something like that, and people would put in, where they are and where they want to get to, and it would calculate and give you this is how you get there. You catch this bus, you catch this train. The cool thing about the app that we built, it was all born in the cloud. It had real-time updates, so we would get if the train was late, it would recalculate, your routes. It would also tell you if the train or the bus was full, and so it would say, okay, get the next bus, or wait 5 minutes and another one will come along and it would be empty. So what I'm trying to get at is the team that we had were very agile. They lived and breathed agile, lived and breathed DevOps, and we built a really great DevOps capability. And it kind of, if you read all the textbooks about DevOps, they really strive to build that model, and it worked really well. The thing about that application, it was a large application. It was the most visited application, government website in Australia, So, there was a lot of finance and it was a high rate of change. So it really supported CI/CD and all the good stuff that you get with DevOps. So in Aviva, we have applications like that, but the majority of applications are not like that. So for an application that runs on one server, it doesn't make sense to stand up a DevOps team to support that one application, that one server. So there are many factors when we're looking at it to work out what kind of DevOps model that we want to put in place. So, does the application team have skills in the cloud? In terms of how do they understand CI/CD? How good are they at automation tooling? What is the application? Does it ever change? And I've worked with applications that I don't think I've ever changed. Over 3 years, we've probably patched the OS and that's about it. So, if it doesn't change, why would you build a full all singing and dancing CI/CD pipeline for something that doesn't change that much? So, if it's a lot of effort to build this automation in and to build a DevOps kind of practice. It doesn't make sense for applications which are small and don't cost much and are not very complex to stand up a huge DevOps team to support that. Probably not. So I guess what I'm getting at is, there's many different DevOps models that we're looking at Aviva and adopting. So for the application teams like digital, for example, they can do the whole stack themselves. They can manage the infrastructure. They can manage the automation. So, if you look at kind of here, they're here. They can do it all themselves. There are many teams here which only know the app side of things. There might be a .NET team. They know how to code really well in .NET, but they know nothing about infrastructure. They don't know how to patch it. They don't know how to support it. So in this kind of model, we're looking for like a shared infrastructure or shared DevOps team. So they would handle the infrastructure side of things, the patching, the automation, the CI/CD pipelines, and these guys care about more the application. And the third one is, a pretty much self-sufficient team, but they might need something like a DBA specialist skills. So that leads me on to the shared infrastructure DevOps team that we're trying to build, and kind of the roles that this team would need. Obviously, platform engineers is probably the key one here, or DevOps engineers. So, doing the application builds, the tooling, the automation, the CI/CD pipelines, configuration management and lifecycle management. Cloud architects to do the application designs and the migrations, and then we're looking at cloud DBAs. So one of the things we want to do is move away from proprietary databases like Oracle and move to more open source ones. Oracle's prohibitively expensive in the cloud, so that's another one of the database strategies that we're looking at. So that's another kind of capability within this shared DevOps team. So yeah, that kind of leads me on to hand back to.
So to give you, thanks, Darren. Just need to get out of the way of the loudspeaker because otherwise I get my own feedback. To give you sort of a sense of scale, at the moment the project, in the project core team, is about 130 people for the size of Aviva. We do estimate, though, once we start that migration train that Darren just showed you, there's going to be multiple hundred, 500, 600, 700 people within Aviva that are busy on cloud at some way or form, helping out with migrations. So obviously we're growing the team, and we're looking at talent everywhere we can to make sure we get the right kind of engineering capacity and capability in there to help these businesses migrate their applications. Yeah. A couple of hundred people on a project is big. Yeah, it needs all to be coordinated. It's a complex beast that you try to manage and get over the line. Some migrations going to be straightforward and simple, an OS upgrade or a version upgrade. But given the estate that we know and well, we also know we're going to get some problem children, things where we completely need to re-engineer the application in order to make it work. Yeah. I think the biggest part, technically, guys, is going to be the integration. Yeah, because it's not only an application; it's almost a sort of a move group or a cluster, where everything is sort of interrelated and interlinked and needs to talk to each other in order to make it work. Yeah. So the level of complexity is enormous, and the project is now a year and 5 months old. Yeah. And we're just now on the brink of starting what we call the execution of the migrations, and that's why we're ramping up, and thought it was a good time to have a chat with you guys. I'm happy to take any questions.
I have a really short question. So, why AWS?
I have another question for you. Why not Azure or Google? There are only a few players that can do magnitude and scale in cloud. Yeah, so that's one of the considerations. I actually think that our final solution will not be just AWS. Yeah, you choose vendors for their strengths and for their expertise. But you need to start somewhere, and you need to build something out. If building a platform takes about a year, imagine having to build 2 platforms, because you need one in Google, you need one in, yeah. So it's. I think Amazon at the time is and for us now is the best solution to scale. Yeah, but I don't exclude that we use other vendors as well. Yeah.
I've got a question. You said that you're using Terraform. If you're only in AWS, why not just CloudFormation?
Ooh, I'm going to hand over this mic.
So there's a few reasons. So one is, one day we might not only be in AWS, right? And we've kind of got one eye on that. More pragmatically, the reason we've been using Terraform is it's got some pretty good features in terms of things like sort of dynamic lookups of resources. So there's something called data sources in Terraform, which is quite a powerful thing, and lets application teams write code that can kind of dynamically discover which subnets it should deploy in, for example, rather than that all being kind of hard-coded. And there's some support for that in CloudFormation, but not as sophisticated. Yeah, you can do some of it, it's just not, or at least we found it to not be as sophisticated, basically. And if I'm honest, the other thing was we had some familiarity with Terraform from previous bits of work, and sometimes that makes a big difference. And we also, certainly when CloudFormation was JSON only, bluntly, there was an element of we just found Terraform easier to kind of read and understand, because a big blob of JSON is quite hard to get your head around. So there's a number of reasons, bluntly, but a lot of it comes down to the fact that we've just got quite familiar and comfortable with that tool, and it does let us kind of write code that's kind of very reusable, and we can deploy lots of times pretty easily. That's what we've found anyway. Yeah, we do, and actually one thing I would say is we have done a little bit of work around custom Terraform providers to plug into some of our. I'm trying to think how to explain this without explaining the whole estate, but we've got an authentication component that deals with routing traffic of applications, and we've looked at writing custom Terraform providers to allow application teams in their code to declare configuration for that appliance. And by using Terraform, they can use one tool that does all of that, if that makes sense. So we are using a little bit of those other features. But we could have built what we built with CloudFormation. It just felt better to us to use Terraform for a bunch of those reasons. Okay.
Yeah, so I got a question about Ansible and Puppet and how it fits in your organization. I mean, Ansible is mostly push-based, yeah, and
Yep.
Puppet is pull-based with an agents. And
Yep.
do you maybe use Ansible for the initial deploy, and then you just make sure that all the machines are consistent with the Puppet, or how it works?
So the way we do that at the moment is that most of the automation we do is at AMI build time. So we're very focused on automating the process of building new AMIs. A lot of that work is done using Ansible rather than Puppet. We do use Puppet in a few places, but kind of where we've come from a kind of core platform perspective is Ansible. Sorry, I could just hear it starting to feedback. And we're using that in effectively the kind of So it's just running on the server itself, if that makes sense, to do the provisioning. We have looked at using Puppet to, as you say, kind of keep things consistent afterwards. We talked earlier about platform features, so that configuration management layer is something that's kind of on our backlog right now, and it's not something we've done straight away. But as applications demand it, we will probably put a Puppet master in. We've also got one eye on the AWS Systems Manager functionality that they've released fairly recently, but that's quite early days for that function. Okay, does that make sense?
Yeah.
Cool.
If I may, before I pass the microphone, well, you did mention about the increasing the capacity of your team, and actually, it's always interesting at Aviva that we talk about economics on the meetups. And well, how do you see the team after you make an migration? Because it's obvious that it should happen, but do you plan to keep the people, or how do you are planning to evolve from the point when you have migrated? Because probably you are not going to fire people just because the work has done, but probably you have another vision.
That's a very good question, and actually I'm struggling daily with that. Yeah. If you see the workload we have ahead of us now during the migration, obviously that is a sort of a mountain that comes, and that will then suddenly sort of taper off once you go more into production. I do believe, however, that this is a revolution that's not over in a year or 2 or 3, because I think once you hit this swing point where people in the business start seeing the benefits of it, they want more. It doesn't stop, isn't it? So they will then ask us to do the applications that we didn't do in the first round, or they want to start thinking about actually re-platforming old stuff because they want to have the newer technology benefiting them. So I think if you look at a company as Aviva, if I currently look at what we have, is it safe to say, Paul, that the vast majority of the people we have on the program on cloud engineering are actually external to us? They are contractors that we hired because we didn't have the skills. One of my tasks is to build that capability in Aviva. No way we can allow ourselves to be only having contractors doing the work. So we're looking to sort of build this capability, and it's going to be a vast capability, isn't it? If we change the half of the IT estate that we currently have into the cloud, I would reckon it is fair to say that we need to change half of the IT in skills and capacity and capability, isn't it? So we have to build it. We have to do it. And this is just a start. So it's not going to be we hire you for the project and we fire you when we're done. This is a continuous thing that Aviva is going to build on. And we need to find the capabilities and the capacity in-house, but we also need to hire externally, because a lot of what we need at the moment we don't have on the bench.
Yeah, my question was kind of tricky, but it comes from the belief that, the whole process would change and the application development would change, and the DevOps or the Ops would be more programmers.
So it comes down to two things. It's what do you want with your career, yeah? Some people like to be in one place for a long time and work. Other people like to do an adventure and move on. They see it as a learning, and they see it as an add-on to their CV, and then start doing the adventure somewhere else. We're in the market because we need to build a skill in Aviva. We're doing this. This is massive. And we don't have the skills in-house to the extent that we can do it by ourselves. Yeah. Obviously, as an employer, then we need to attract people and keep being attractive for people. Otherwise,
Michał is doing a good job.
That's good to hear. Good question. Same question, yeah? Anyone else?
Hands up if anyone else would like to ask a question. Okay.
Maybe one general question. Where are you with this migration? How many applications? What would be the percentage of these applications that you have succeeded so far with? And second question, how do you deal with these like vendor applications? You have SAP applications, you have a number probably of different applications. How do you deal internally with that, especially that you might have SAP or other vendors delivering cloud services?
Okay, that's a difficult question to answer, but with a number 1, 2, or 3. Yeah. So, as I said before, it's not, you don't look only at applications, you look at move groups. Yeah? So you look at clusters of applications that belong together because as a whole, as a cluster, they do something that we need to port. We have set up a considerable amount of business in AWS native over the last year and a half. We are at the start now of going direct, but in non-prod, we already have quite a lot in direct. So we're working already with over 100 applications where people are doing the engineering in non-prod to get us up to the level where then we can say, okay, now you're ready to be pushed into production. Yeah. On the production side, it's very low because we need to hit a number of hurdles before we can actually go live. Yeah.
How about vendor locking? You're now in AWS, and how would you like to deal with that in the future? For example, when moving across the clouds.
Very interesting question, and it's always asked. There's two things. If you want to use broker tools, yeah, and try to move things between vendors, you basically condemn yourself to the lowest common denominator between them. And that would probably be somewhere as basic compute and basic storage. And that's where it stops. So if you want to go further than that, you need to take and lock yourself in. Now ask yourself a question. If you have a data center and you outsource a data center, are you locked in with that vendor for 10 years? It's the same thing, isn't it? So you choose.
One thing I'd add as well is because we're encouraging teams to script all of their builds, you can use things like Packer, you can use in multiple environments. If you've scripted an application install that works in Amazon, there's a pretty good chance most of that will be good in a different environment as well. In a traditional data center world, when we move data center providers, it's pretty hard, right? So you're into manually provisioning servers and deploying new software on all of those servers, etc., manually. So I think what we're doing positions us better for migrating between clouds than we would have been in a kind of data center world. But we do want to use those features that Amazon provides that aren't just the real basics. Particularly in the kind of digital space, because we just can't do what we need to do without using some of those advanced features. So we've definitely got one eye on looking at other cloud providers, but we weren't willing to pay the price of kind of being in a position where we were only able to use things that we could use in every single cloud from day one, if that makes sense.
Approach. So for example, the cloud formation versus Terraform. So we want to build skills in Terraform so we can reuse that if we need to in other places. If we did it all in cloud formation, then you're going to have to choose something else in a different cloud or on premise. But Lambda, for example, is really powerful. So yeah, it's a degree of lock-in, but the benefit it gives you outweighs that lock-in.
I'd say the other aspect of it is a lot of what we've done that really is quite locked in is around kind of the security tooling and that side of things. So the reality is when you're doing security, you need to understand what's really, really happening. So you can't kind of treat all clouds as equal and assume that that'll be okay, because it's just not, right? The world's just not that simple. So we use a lot of things like Lambda, we use a lot of that in the core platform, because actually that's the best way of understanding what's going on in the estate. But as Darren said earlier, what we haven't said is it's carte blanche for all application teams across the estate to use Lambda, because we're conscious that is a source of lock-in that would be very hard to get out of. So things like that will be much more selective about rolling out broadly, whereas things like RDS, which is managed database services, using that just makes sense, because the reality is you're locked into Postgres at that point, or MySQL, not AWS, if that makes sense. Yeah?
Any more?
Do we have any questions? I think we've done. Okay, so big applause for Mark, Darren, and Paul. Thank you very much.